So that is the requirement for and also the network has to be highly reliable. Okay, that's a very important vision that required in the 5G. With that, we need a capacity. You think everything is connected, talking about 29 billions of the connected devices. Capacity means, according to Shannon law, you need to have more bandwidth. If you see here, the bandwidth below 6 gigahertz, 2G, 3G, 4G, all below 6 gigahertz. Not enough bandwidth to cater for the band that you are looking at. Okay, and that's why they are looking into millimeter wave band. In WRC 15 last year, they are looking into zooming further before they say above 6 gigahertz. But WRC 15 November last year, they're looking into zoom into 24 to 86. These are the potential band to be used in the 5G, which will be decided in WRC 19 later. And one of the very potential band they are looking at 28 and 38. Most like FCC in US and few others, they are looking on that. And those are the potential band that will be for initial stage of implementation for the above 6 GHz will be 28 and 38. That's maybe a potential band. And if you're looking into that, you need to go to this band, and besides that, we need to have a good signal to noise ratio, which means you must be always close to the base station. So one of the things in the requirement 5G, the cell will be small. They are looking into 200 meters. And the beam from the cell will be a steerable beam, will be additively improve the user. So if that we can provide a good signal to noise ratio and so on. Okay? And besides that, massive MIMO is a must. You're looking into LTE, talking about 4x4 in base station. MIMO means multiple input and multiple output. LTE to get 1 gigabit of data rate, you need to 8 by 8. And of course, you need spectrum of 100 megahertz. That's why in LTE they have carrier aggregation. Below 6 gigahertz, you cannot get one single spectrum with that. That's why they can have to aggregate 900, 1800, 2 gig and so on, 2.6 and so on. But when you're looking into provide higher, then there is no more spectrum, then you have to go to the millimeter wave. The advantage of that, the antenna size to be smaller. You need an array for that. So this why. So with this, we are focusing on this band to look into for future application in the 5G. So I think with that, we have this collaboration with Ericsson. We have one to identify the research area that we will be looking at. Second, we are talking about the 5G research lab, and we also talking about the the learning experience, the training center. For that we can use it for 5G and also 2G, 3G and 4G learning center for that. So these are the areas that we are looking at on propagation study, which mainly involve the spectrum. We are talking about in 28 and 38 gigahertz. Antenna study, we're talking about the antenna having the beam steering and so on. And sustainable and safety study, that means it's more related to the radiation, EMF. 2G, 3G, 4G, there are many base stations surrounding us. So when you're talking about 5G, one of the features is a small cell. There will be more base stations. So we will be looking into what will the effect of this, the EMF, the radiation. And the second phase, maybe we're looking into wireless communication network and security. To look into a bit more detail, these are the areas that we are looking at. For example, we are looking into the characterizing the band, 28 and 38, both narrow band and also wide band. We are talking about 100 megahertz of bandwidth. Then we are very important to characterize, to sound the channel. So the equipment you see in the 5G IC can sound the channel and do those measurements. And other thing that we are very important for the local here is the rain attenuation. As you know that tropical region like Malaysia, in millimeter wave band, especially 28, 38, will very effectively because the raindrop size is small, bigger, and then your wavelength is small, it can be scattered. That's why in some satellite reception antennas, broadcasters, like when you have a rain, you have problem. So what happens when you implement this 5G here using the millimeter band. So these are the things that we are looking at. Antenna, as I mentioned to you, are looking into massive MIMO phase array, and we are looking into sustainability on the effect of the electromagnetic to human from the base station as well. So those are the areas at the moment, and the second phase we are looking into radio over fiber. Okay, so I think one of the things that you see, this basically you are talking about when the spectrum in the 28 will be saved in the videos. So what happened to the current services? So for example, this is the spectrum allocation in Malaysia. We are looking at two bands for this our study for propagation. One is on 30, the other 40, which means we are focusing on 28 and the 38 band, looking to add frequency. Here is the what we proposed by ITU in the WRC 15. It's a potential band beside not below 40 gigahertz. We're looking to 28 and also 38, and we're looking to the current services still available. 28, another band is being proposed by other countries, is potential to be used for 5G, and it's potentially, you can see that some services already available at that band. So we'll be looking into coexistence, and also we're looking into adjacent coexist with different bands. So this is very important for not to look at what the issue there. For example, some of the applications is already there, like point to multi-point and so on. So this has to be considered when they are talking about when the 5G is being introduced. Okay, I think with that we need to characterize those bands. So we are looking into basically focusing on 28 and 38. And we have to characterize both outdoor to indoor, and also indoor. And basically we are also doing below 3 gigahertz. So the thing that we want to see now, to make comparison, when you move from the current below 6 gigahertz to the higher band 28, 38, what is the difference? What are the effects? Okay? Both indoor, outdoor, and so on. So we're using this channel sounder to look at that part. And with that, we are also looking into the range. Because, you know, the range is, they are talking about point-to-point microwave link, for example, maybe 5 kilometer, or satellite path. Where slant path maybe up to also 5 kilometer maybe. If you look here, the highest rainfall rate in Malaysia, average, maybe can say 140 millimeter per hour, compared to maybe in the temperate region, maybe 20 or 30 millimeter per hour. If you, from this graph, we can predict that per kilometer it can cost about 30 dB per kilometer. If you have a microwave link, 5 kilometer, with 30 dB per kilometer, for sure the link will be out. We have 150 dB drop. Same with the satellite. Even you can see satellite reception today operating in KU band. This is 12 gigahertz. So what happens if you operating 5G in 28 gigahertz? Even worse. Okay? But you'll be looking, some theoretically you can see that coverage or the cell of the 5G only 200 meter. If you're looking about 30 dB per kilometer, you're talking about 200 meter, only 6 dB. So 6 dB is still acceptable. And again, the beam in the base station is focusing to the user. Okay, that might be no issue in that, even in the tropical region. So which means that we can still utilize the millimeter wave band in the tropical region with that. But we need to study that. We need to investigate what happened. So that's why the sounder that we have, for example, can do some measurement just to make sure that what happened 28 and 38. Because 28, 38, globally, it can be a common band, okay, for the 5G, for example, right? So what happens if that be used in Malaysia, with range attenuation and all those things? So that's important for us to look at. Even theoretically, people say that no effect, because 6 dB is, you can compensate for that, with a small cell. But of course, for long range, for point to point, might be that an issue there. Okay? So that's one thing that we are looking at that. Other thing, we are looking into the antenna. As we mentioned to you, the antenna from the 5G base station will be centerable. It's just like a spotlight. 2G, 3G, 4G, we are the omni or centralized, fixed. But in 5G, you are talking about following the user. Okay, once you have been there, and then you have multi-beam surround. This is one of the concepts in the 5G they're looking at. Okay, so that one also we are looking into the array and so on. So the beam will be following the user like that. So this is a concept in one of the features in the 5G. Okay, besides that, we are also looking into the radiation. People now worrying, even 2G, 3G, 4G, you have a base station surrounding you. What is the effect of the radiation that people, you can see that we have this measurement done, 5 sites, 2 in the south in Johor, 1 is in Kuala Lumpur, and 2 in Penang. So we are putting into different environment. We have a rooftop, we have all the where people moving around, and actually you can see that the measurement that we have done, the data being collected is less than 10% of what the minimum set by the ICNIP. ICNIP is a non-ionized standard. You shouldn't, if you reach 100%, it's still safe. But actually the one that you are receiving from the base station basically less than 10%. Because what happens is, when you transmit, it's going to spread out. What you are receiving only a small portion of what being spread out over there. Okay, so these are the even if you are looking into the handphone has to communicate back to the base station. Even the signal from handphone is much higher than what the signal from base station coming to you. So you have to transmit back. But even that, from there you can see no issue actually. But what happened when 5G is coming? So now we are looking also with the Ericsson. Actually, we have a team in antenna propagation and this EMF discussing together directly with Ericsson Institute, a group of researchers that coordinating by Ericsson Kuala Lumpur. So we are looking into the future, what happened when we have 5G. We are focusing today. We are looking into how much the power density. Okay, so at the moment we're doing on the simulation side. So these are another area they are looking at. Okay. So with that, I think besides the research, we are looking into the R&D, as I mentioned to you, looking into high impact joint R&D, where I mentioned to you that we have a collaboration directly with the Ericsson Sweden, coordinated by the Ericsson in Malaysia. And, we are expected also to have some sort of joint publication. As in our university, we have to do research. So one of the things that maybe we need to publish. Okay. And we have to sharing a mutual knowledge sharing and so on. Okay. We are also talking about providing training to the industry, to the university, not to our student, postgraduate student and so on. So we are joining with the Ericsson on the training programs and lifelong learning. And another thing is that, as I mentioned to you, you can see in the 5G IC is the showcase of what will be the 5G. It's important for us to educate people. 5G, will be 2020, 4 years from now. And 5G is different than what we experience now. 2G, 3G, 4G, you're talking more about evolution. First generation to second generation is more toward revolution. We are changing not analog to digital. When you come to 2G, 3G is more talking about bigger pie. But when you come to 5G, not only evolution, you are still continuing with evolution. Of course, when there is no 5G, you move to area where there is no 5G, still can be, but you will fall back to 4G and so on. Same what has happened now. 4G, you move out, no 4G, they will go to 3G. 3G, now you go to 2G. But when 5G coming, the evolution, they will still do that. But besides that, they are also become revolutionary. That's what we mentioned by Dr. Imadul, there will be things are all connected. That's why you are talking about 20 billion connected devices. That's why you need to have capacity. Besides broadband, because 5G not only talking about broadband, it's talking about connectivity. You're talking about very high reliable. You're talking about latency. Latency is 1 millisecond. You're talking about remote surgery and so on. Very important. Automatic and so on. So this is what will happen. Okay. So we set up this 5G IC here. Just one thing is to educate, so that people can understand. Before 5G, by 2020 coming, we already, and we can see that what are the use cases and so on is possible. So some sort of that. So these are the 3 areas that we are focusing in the collaboration with the Ericsson. Okay, I think with that, thank you very much.
Thank you very much, Prof. Tharek. Before we close the 5G talk, I just want to check whether there's any question from the floor for both Professor Tharek as well as Dr. Imadul.
My name is Martin from Maxis.
Yep.
To Dr. Tharek, whether E-band could be a potential ban in Malaysia? E-band. 76 to 86.
E-band. Oh, E-band. Yeah.
E-band for Malaysia.
Yes, I think basically E-band, we're talking about above 60, 70 gigahertz and above. Because in WRC, before when they set out they're looking to vision and then provide the requirement for 5G, they're looking to above 6 gigahertz. And when it comes to WRC 50 last year, they zoomed into 24 to 86. Which these are the potential band. Not decided yet, but these are the potential band that will be decided in WRC 19. So E-band, the 72 is one of the band. As I mentioned by Dr. Imadul, the initial phase of introduction, maybe you're talking about 28, 38. That is a potential band. That can be a globally harmonized because you require that. Otherwise, what we explained, we have a terminated. The next one is the unlicensed band. 60 to 66 can be on. And I think they are looking into for 70 gigahertz and above. That's second, because at that frequency, that will be. So in between that, we don't know. But by WRC 19, this will be decided. But potentially, I think 28, 38, if you look into most of the use cases at the moment, they are looking into that both those band as initial implementation of that.
Dr. Imad, would you like to add to that question as well?
Yeah, thanks, Professor Tharek, for this comment. So actually in 3GPP, we are studying all of the range from 24 until 86. So we are studying, let's say, 24 to 29.5 gigahertz. Then we are studying 37 to 42. Then we are also studying, for some countries, it's 49 to 54. And then you have 60 to 66, which is the unlicensed band. And then we have 71 to 86, which is the band that you mentioned. So in TEPP, we are studying all of them. And then depending on which spectrum gets really used in different parts of the world, that will actually define what real products will come out. But there will be solutions that will support all of this spectrum.
Any additional question from the blog?
I think it's similar to what happening now. Now we have 2G, GSM. We also have 3G, WCMA, HSPA, HSPA+, and we have LTE 4G. They will be there. Of course, I think you experience now also, and for example, this location we have a 4G here. So your phone will be go to the 4G unless you change you can force it to be other. But automatically, when you go out, they will fall back to 3G and so on. But when 5G can be one of the things, they still, because your phone, when the specification has been finalized by 2020, after we harmonized and separate anything, then when it's mentioned, then we have the device, we can support that. And the same thing happens, that's why called evolution. When there is, say now we have 5G, you can experience 20 gigabit or 10 gigabit, for example. So you move out, there is no 5G, still can be connected, but you fall back to, say, LTE or 4G. You move further, it is same. What's happened now? We have 4G, fall back to 3G and 2G. So it's same thing, there is evolution. The only thing difference that when you have 5G, you are connected to things, devices, and so on. When there is no 5G coverage, then that will be a difference. But in terms of the device itself, in the broadband, it's still the only your experience will be different.
maybe I can come at that more from an operations perspective, because I think it's a good question. All too often we want to know how much the electronics cost, but we don't think so much about the life cycle of maintaining a network. So we see now in a number of countries actually 2G being shut down. And the reason for it is, one is because there's a high net penetration of smartphones, and so you can use them. But another reason is, of course, to reduce the operational expense. We can remove a layer on the tower, you might save 50,000 ringgit per tower per year, for example. Those costs matter. I mean, 85% of the cost of a mobile network is related to, is not related to, say, electronics. It's related to the life cycle of having many towers and so on. It's a lot, actually. So I think it's an important consideration to think about how to make the optimal use of the spectrum, try to reduce where possible, because you guys are having lots of fun with very tough prices on each other. So I mean, that price pressure won't go away, right? So the pressure will always be there to try to find ways to make money, and you have to find ways to reduce the operational cost, for sure.
I think Todd has said very nicely, but I just want to also remind you that, so we have shown this network measurement where we also show that if you actually have a good interworking between 4G and 5G, then you can also actually enhance the per user throughput. So that was the slide that I have shown. So the point is that we feel that interworking between 4G and 5G will be very important actually. And how do we manage it in the real deployment scenario that will really define what kind of performance we get. So this is what we showed here. So this is on the live network measurement. And so if we have a 40 gigahertz bandwidth in a 4G, 2.6 gigahertz, and with 100 megahertz bandwidth for a carrier above 6 gigahertz. So we actually see that for a very high data rate requirement, usage requirement, 32 gigabytes per user per month, we actually see that 95% of the users get more than 98 Mbps. So 5 percentile is on 98 Mbps. So actually interworking really provides a good solution.
Thanks, Tharek and Todd. Is there any further question? If not, I can raise one question, because this is something that I received from some of you before we start the session, because I think there's a few of you that asked me how can OpCos or other industry that attend the session today can be involved in this collaboration between Ericsson as well as UTM. Maybe this is a question for both Professor Tharek and Todd, in terms of how other people can join this collaboration.
Can I also put that? So I think basically, as mentioned, that 5G IC is basically a collaboration between UTM and Ericsson. And of course, we are talking about 5G. And we are showing the showcases that potential application. And as we see that Ericsson also collaborating with others. So we are open basically. So from this experience, that's why we are all open to all the industry and all to come. And maybe they can have some input and also that we can share and also we can collaborate further. Maybe talk to them.
Yeah, Rob, that's absolutely right. So we're starting with the partnership of UTM and Ericsson, but and you can look at the sign outside. There's plenty of room for their logos there. But more seriously, I mean, if we really want all these use cases that were presented to really make that happen, so that it has an positive economic impact in Malaysia, it's nothing that UTM or Ericsson is going to be able to do by themselves. I mean, it needs to be industry partnerships. If we want to help transform the utilities industry or oil and gas or oil palm, etc., we need to have lots of industry and academia coming together with support of the government. And it has to be that way. So hopefully this can be a platform for partnerships for other players. That's what we would like.
So if there's no further question, that's the end of the 5G talk. So we can continue with the flow of the demo. If you are interested, you can go to the next door. But if you also like to learn more about consumer currency, then I'm happy to discuss it with you. But that's basically the end of the 5G talk. Thank you very much.